My name is Jeremiah Polo. I'm an Android developer at Weather Care Solution in Kisumu. So today I'll take you guys through flowing with Kotlin for flows. The topics that we'll cover is what flow is, state flows, shared flows, and the use cases of flows. Before we begin with flows, Kotlin in many ways has helped us do a synchronous process in a very simple and cheaper way instead of straining too much in multi-threading. So, hello. So, Coroutines provides a way that Android developers or provides a way of connecting or linking our applications to a remote server or a database that requires a long process or takes time before a result is sent back to the user. So, for example, here we have a synchronous blocking code. So, a synchronous operation is an operation that runs immediately, and the results should be returned to the user. So we can see here we are fetching data. We're fetching user data from an API, and after we fetch the data from the API, we present it to a user. But with this code, it comes one drawback. When we call the fetch user API, the main thread or the thread in which this function was called becomes blocked. So when the Android system tries to print or display anything to the user, it fails because some operation is blocking the UI thread. For example, you can see here we have called the fetch user, but when the system tries to write anything in the application, it fails, and the user can see a blank screen or a hanging thread. And that, in a user experience perspective, immumanjays. So that's where coroutines come into place. You can see the blocking code and the coroutine code are similar, because the only difference comes in we have added a suspend modifier. So this suspend tells the coroutine or the compiler that this code should be run in a coroutine scope. So we can see here when the user calls the API and says fetch user, a new thread is created, the network thread, and you can see here the dotted line represents the let's say the UI thread. You can see it is dotted. This is because when the load user is called, the thread is suspended and a new thread is created. So in this new thread, the network thread, that's where all our computation is done. And after the computation is done, the response from the API or the data from the API is sent back to the user. So as I stated earlier, suspend function or coroutines should be called in a coroutine scope. So what is this coroutine scope? A coroutine scope is like a wrapper in which determines the extent or the extent in which a suspend function can run or a coroutine can run. So all coroutines should be called in a coroutine scope. If we call a suspend function or in let's say, if we do not call a suspend function or a coroutine outside the coroutine scope, the compiler will show you an error that suspend function should be called in a coroutine scope. Another use of coroutine scope is to keep track of all the coroutines. We can have one coroutine scope that calls different endpoints or different APIs. Like we can fetch a user data, then we fetch the details of the user. So those two, we can have that. We can use that one API or that one coroutine scope to call those different APIs or those different suspend functions. Another good thing about Coroutine Scope is that you can cancel coroutines. So let's say our coroutine should live, let's say from a life cycle. Let's say coroutines are always tied to life cycles. For example, in an activity or in a fragment, when a coroutine can live from on started to on destroy. So when on destroy reaches, all other coroutines are coroutines that were started from our coroutine scope will be removed and cleared. A coroutine scope can also notify when there's a failure or when there's an error between our computations. So this is an example of coroutine scope. So we can have in Android KTX library, we have this custom-made scope for us. For example, a view model scope. So view model scope lives through the life cycle of a view model. So as we know, a view model helps us to keep our data, even if our fragment or our activity dies or is not disabled. You can see when we call this function like fetch and show user in this coroutine scope, data will be sent to our coroutine. But when the coroutine scope is destroyed or is cleared, all the children or all the coroutines that were called from this main from this view model scope will be destroyed. Also, let's say in our activity or in our fragment, we have a lifecycle scope. They're all bundled up in the Kotlin KTX library. So when the activity is created or when the fragment is created, and we call fetch user data, fetch and show user, the details on the data from the user will be called and the data will be sent to this coroutine. But when the fragment is killed or the fragment is destroyed, we'll be able to, the coroutine will be cleared and all the children or all the data that were created from this scope will be destroyed. This helps us to prevent memory leak because let's say when a resource or when a coroutine holds on to data, will have memory leak because those resources should be used with other people, but this guy or this person who is not cleared holds on to the data. I hope we are clear there about coroutines. So let's start with flow. So what is flow? In coroutines, it's a type that can emit multiple values sequentially as opposed to suspend function that returns only a single value. So flow helps us to get multiple values. For example, we are fetching data from our DB, and in the API changes data and send it back to the user. We can be able to track and see all those changes and all those new data as they propagate to our as they propagate. So why use flow? First thing, flow is powered by coroutines. You can see here, let's say we want to fetch data from our user, from our endpoint. For example, here we have get user. We can be able to suspend operation and get data without blocking the UI thread. So that's one good thing about suspension. You can fetch or do long-running tasks without interfering with the main thread. You can see the other thing about suspend function is that they can be called one after the other. For example, here we can fetch the user data, and from the data that we've gotten from the user, we can be able to get the favorite movies of that specific user, and then we emit them to the coroutine that is listening to these changes. Structured concurrency. So structured concurrency, as you can see in the example, we have one coroutine scope that can be used to create two different tasks. For example, in the first one, we are getting the user data, and the second one we are fetching the favorite. The goodness about the word coroutine is that all of this will be stopped once the coroutines is cancelled. This will help us to prevent memory leaks, and memory leaks are always bad. Flows can also interpret with reactive stream. So we have many ways in which we can have reactive. We can be able to handle reactive stream. For example, we have RxJava, and we also be able. RxJava have been used for a long period of time, and it has some, let's say, shortfalls or some limitations. So we can be able to, both of these RxJava and Kotlin Flow are built on top of reactive stream specification. This is a specification that entails on how reactive streams will operate. So let's say we are trying to migrate our code from RxJava or Rx Kotlin to Flow, or vice versa. So we can be able to, using an extension function that's as bundled up with the coroutines, we can be able to convert one object to the other. For example, we have here, we can convert an observable, which is a way that RxJava sends us reactive streams of data. So we can be able to convert a flow we can be able to convert an observable to a flow. So when should we use coroutines, or when should we use flow? Anyone who can give an example where you can use coroutines and where you can use a flow? Flow can be used to emit sequential data. For example, let's take an example of Instagram application. An Instagram application, we have the post and we have the likes. So Flow can be able to get the number of likes as they come in real time. So let's say a person in Webuya has liked your post, it will propagate and you'll be able to view it as it comes. A coroutine can be used when you want to fetch one-shot data. Let's say you want just to fetch the user data from the database, but we don't care if the data can change, or we're not interested in the reactivity or when the data changes immediately. So there's something here about cold stream. So flows are cold streams of data. What does cold stream of data means? So for example, here we have a countdown, which emits 3 values delaying 100 seconds. And we have here a coroutine that collects. So in Flow, we do, like in LiveData, we observe, but in Flow, we collect. So cold stream states that cold stream means that the data will start to be generated only when a terminal operator like collect is called on them. So we can see these 2 boxes represent the first one is the flow, this flow builder that creates the flow, and the second one is the collect. You can see that both of them are gray. This means that the flow is not emitting any data, and the collect is not yet called. So once we call a terminal operator like flow, that's when both of them becomes active, and data will start streaming. Components of a flow. What components of a flow? So we have a producer. A producer is the person or is the object that creates the data that is emitted to the stream. For example, here we have a flow that emits three names of people. We have Jen, we have Mburu, and we have Mungu. So a producer in an Android context, we can have our backend or our remote data source that emits name that emits a list of users. So that's one of the examples. Another example, a UI can also be a producer, because we can get data from the user and use that data to fetch or to do some other operation. Consumers. So consumers are consumers, they take in the data that has been produced by the producer. So when it is, as I said earlier, collection or emitting of data from a flow is only triggered when a terminal operator like collect is called. So let's say we're getting data from the UI or from the endpoint, and we want to start triggering the incoming of the data. So when you call a collect, that's when all the data will start streaming. And that's an example of a consumer. Yeah, we also have intermediaries. So these are functions that modify the stream of data without consuming it. Consumption of data only happens when a collect or when a terminal operator that's collect is called. So this time intermediaries can change the data before it's collected. So let's say you're fetching the names of people from our backend. When you call on each, we can be able to do an operation on the data. We also have another one which is called map. Let's say we are converting a data from one type to the other. We can use map to convert this type from type A to type B. And the good thing about this is that we can create a chain. We can create a chain of intermediaries. We can have on each and on map called one after the other. So code flows only emits data from when a terminal operator, let's say when a terminal operator is called on them. Let's say we're fetching data from a database. Code flows only emit data when a terminal operator is called on them. So what are the drawbacks of cold flow or of cold flow? So let's say we have a flow that emits data. That's the top one. If we call if we collect from this flow twice, data will be emitted to us twice concurrently. So let's say we're having our database, and one view or one use case, or no, when one view calls on the data and another one also does the same, two operations will be created. That means the database will be accessed twice, and that can lead to wasting of resources and wasting the user battery. So in our daily operation, we want hot flows. So hot flows are flows that produce data even when a user, or even when there's no consumers consumers who are consuming our data. So we have three types of or three data holders that can be able to convert flows to a hot stream, or to convert flows which are cold to hot flows. An example is LiveData. We also have another one called shared flow. We also have sorry about that. So let's go back to, we have LiveData, we also have shared flow, and we have flow, and we have state flow. LiveData we have been using LiveData for a while, but LiveData comes with some limitations. So, for example, we have nullable values in LiveData. Let's say even if you create a LiveData and instantiate or have or start or instantiate a LiveData with a value, we must always do a null check to that LiveData, even if we know we have an null value. Another thing about LiveData is that it does not support multi-platform. So LiveData is bundled up in the Android X lifecycle package, and that means we cannot have it outside the Android context. So if we do want using LiveData, so what can we use? So we have shared flow. So shared flow is a flow that allows for sharing itself between multiple collectors, so that only one flow is effectively run simultaneously to their collectors. So let's say we have our remote data. Like, let's take an example of let's say dollar or Kenyan shillings, and we know these values can change over time, and we want different screens to be able to use them. So we can just declare a shared flow that converts a code flow into a flow, and different operators or different different objects can be able to listen and collect from a shared flow without creating new instances. So we can as I said earlier, a disadvantage about flow or cold stream propagates data when a collector is called on them. So if you collect them twice, you can be able to 3 types of data or 3 instances of the collection will be created. So how do we create flows? How do we create shared flow? So we can see they're more or less similar to LiveData, but with a mutable shared flow, we have a replay. So a replay is the number of values that we want to be emitted to all the consumers when let's say one consumer comes late and the other one comes late and the data is already being propagated. Shared flow will can be able to give you all the list of the data that was sent to the other collectors, and that can help us keep track of what data has been sent. So we also have 2 types of shared flow. We have the mutable one and we have the non-mutable one. So to convert a mutable shared flow to a non-mutable shared flow, we just call an extension function which is called a shared flow. So that will convert our shared flow into our flow. So this is how shared flow is built. It has a replay cache, which I've said is the number of data or the number of items that we want any new collector or any new collector to receive. Mutable LiveData has 3 operators, although one of them is still in experimental. Try-emit is used to send the data into our shared flow. Subscription count, which is a shared state flow, gives us the number of subscribers who are observing or who are taking in our our data. So in an Android context, how can we use shared flow? So shared flow, we can use it when we have different consumers, or when we want to trigger an event to different consumers to listen to them. Like let's say we are downloading items from, let's say we are downloading images from the internet, and an out of memory is called. We can be able to propagate that event to different consumers, and all of them can be able to see that there's out of memory. So let's stop this downloading because the user does not have data. We also have let's say we want to get, let's say we are building a tracking app, and we want to see we want to keep track of the data of the coordinates that the user is going. So we can be able to trigger a shared flow and send all the different data to all the consumers. In the previous slide, we have seen that we can create. In the previous slide, you can see that we create a shared flow using a mutable shared flow, initializer. So we can just do mutable shared flow and give the number of replay, which is the number of items that should be propagated or should be sent to the user. Another way is to use a function, extension function called share-in. So share-in takes a flow and converts it into a shared flow. This can help us to remove boilerplate codes from our view model and have the producer who's generating the values to be a shared flow. So first thing, a share-in function takes three parameters. The first one is a scope. The second one, we have the replay, which is the number of items that we want to send to our user. And the third one is started. So started scope. This scope is the coroutine scope that we want our flow to be, launched in. When we have different consumers who are consuming our data, we will have to pass a coroutine scope that outlives all of them. Let's say we have a view model. If a view model scoped in a fragment starts a flow, and the flow is shared between different consumers. When the view model is destroyed, all the data or this flow will stop creating the data, and other observers cannot be able to get the data that they should. So we can scope our view model in an activity so that it outlives all other fragments, and the data is available to all the consumers who are the children of an activity. We also have this guy called stateflow. So stateflow is a stakeholder observer that emits the current and new states to its collectors. This is more like a LiveData, but LiveData that has the benefits of Kotlin and Coroutines. So we can create this is how we can create our flow by using the immutable state flow with an initial value. So this initial value is the value, is just a folder that will be sent first when different collectors or different observers are taking this data. Let's say the inner workings of a state flow. You can see we have only a value as compared to shared flow that has a replay, which is a list of data that should be emitted to a user, to a new consumer of a data. So we have shared flow, no, state flow, state flow and a mutable state flow. So mutable state flow can able to change and get different data as compared to a state flow, as compared to a state flow that only emits data. So in an Android context, where can we use state flow? So state flow can also be used, all the places that we use LiveData, state flow can also be substituted for it. For example, we can check the state of a user. Let's say a user is logged in or a user is signed out, so we can be able to get the different states of different states. We also have like a logging state. Let's say we are fetching data from our remote source. We can be able to get this data. We can be able to show the UI, the state in which our operation is going. So we can have a loading state, an error state, and also a success state. So what's the difference between state flow and shared flow? State flow has a value operator. Hence, you can access the recent value, while shared flow has a list of previously emitted data. So this means that let's say we want to get the current data, which is only one. We want to get a current data. We can do a dot value of operation to it, and we get the latest state of our data. But in shared flow, we get a list of data, or a list of the previously emitted values. State flow conflates data, while shared flow does not. Let's take an example. We have two consumers of data, but one is slower than the other. So state flow will only send you the data as you collect them. But shared flow, let's say you are late, or the function is slow. Whenever it comes, we can give them the list of the data that were emitted. A good example, let's say we are in our home set, and there's some chapatis kwa meza. So we can have like 3 people who eat differently. One can eat faster than the other. So with state flow, let's say we've given the first round of chapatis. All of us have gotten our share. The next time, the next time we're given, everyone can be given their chapati. But let's say one of us is a slow eater. What happens? A state flow will skip them and proceed with the other ones. But shared flow will give them equally. You just wait for, you're slow, don't worry. I'll keep yours, and I'll give you as you become active. So what are the difference between state flow and LiveData? So LiveData has an initial value. State flow requires an initial value when we are creating it, but a LiveData does not have an initial value. Another thing is LiveData automatically subscribes its observers while Stateflow does not. So LiveData, let's say we are observing it, we give it a lifecycle owner. When that lifecycle dies or is destroyed, LiveData automatically stops the execution of that emission of data. But with Stateflow, it does not. Stateflow will remain there and just observe you. To achieve functionality like a Stateflow, to enable Stateflow repeat or act as a live data, we have to call we have to use lifecycle dot repeat on lifecycle, so that we can lifecycle dot repeat block. Lifecycle dot repeat block requires an initial state. Let's say we have the on created, on started or on created. So we can state in which lifecycle or state that we can be able to start or stop our shared flow. So where can we use flow, shared flow, and state flow? Room. So let's say we are using our room database. We can be able to get flows of data by wrapping our flow, our result in a flow. So one thing that we should know is that we do not have a suspend function, a suspend modifier in our function. This is because flow itself is built inside using coroutines. So the flow already does everything on a background thread. So let's say we are fetching data from our what we call this, or from our endpoint or our like this one. There's a problem here. Let me exit this. So retrofit also supports use of suspend function. So let's say, for example, so let's say we want to fetch data from our endpoint. With the retrofit, we just mark that function with suspend, and we can be able to get the data as it comes. So that's how we create data. We create there's a screen that is missing here of the implementation of using retrofit. It's the same as room, but with retrofit we just mark that function with a suspend modifier, and we can be able to emit data from it. So an example is in our repository here. We create a flow using a flow builder like this flow. So let's say we are getting the list of movies from our endpoint or from our remote source. So we just call the suspend function. Just call the suspend function inside our API, and data will be fetched. So that's how we can use it in our repository. we just call an API that has a fetch, has the that has we can we just call it and check if our data is success or not, and emit the values to all to the flow. So we can see here we have an emit that sends the data to our flow, and every person who is collecting or who is consuming this data will receive it. So data has been propagated from our repository to our UI. So how do we collect our data? So as I stated, we use to make it that we don't waste resources. We call it on a repeat on life cycles. Repeat on life cycles. So as we have here an a state or state that, or this state is the least state that can be used to start our collection. So we can just call the view model upcapping move state, and we collect, and we can be able to get all the data from our flow. So flow helps us to remove callbacks from our code. So let's say, for example, we are fetching data from Firebase. Firebase Firestore has like three events. Let's say it has it has three functions that we can get different results from it. We have like on error and on new value. So to remove all those boilerplate from our code, we can use a callback flow. So a callback flow converts a callback-based service into a flow. So we can be able to listen to changes as they come synchronously or asynchronously from our Firebase and emit it to all our consumers. So the goodness about callback flow is that you can close it at any given time. So let's say we wrap our instantiation with a try catch block. So let's say an error has occurred in the stream like that. We cannot be able to instantiate our collection reference. So what should we do? So we can just send an the error to our collectors and close our stream of data. So with Firestore, we have on snapshot listeners. So with this one, with the callback flow, we can add a listener and be able to get all the events as they propagate. So we can have an on snapshot listener and get every single data that comes to propagate it to propagate it to our collectors. Finally, we have an await clause. So this await clause, callback flows can close at any given time. So let's say when there's an error, we close it, our callback flow will stop emitting the data. But when we have an emit clause, this will wait for, let's say, we want to unsubscribe from listening to changes of data from our Firebase. Await clause removes the subscription when the endpoint stops, when our Firebase stops sending data, or when no one else is listening to the data being propagated by our callback flow. And that's the end of my talk. So anyone with questions on what we have covered?
Hello, I have a question. Could you please maybe make some clarity on the difference between the cold flows and the hot flows?
Cold flows only emits or generates data when a ternary operation like collect is called on it. But shared flow but hot stream flows produces or emits data even if someone is not collecting the data.
Okay, I get you. So how about, so if you're talking about even without being collected, does that mean that maybe it would just be disposing them off without any collection, because I believe they should be triggered in some way?
So hot flows give us data even if no one is collecting them. So this helps us. This helps us in this way. So let's say we have if we are fetching data from our remote source, and we want it to be triggered only once. So our flow will produce the data, but our flow will continue producing the data, but our hot stream, let me refactor there. Hot stream sends data even if we don't have consumers. But cold stream only sends data when there's a person collecting them. This helps us in this way. So let's say we have a flow that fetches data from our database, and we don't want it to be triggered many times. So our flow will have our cold flow will send the data send the data only when someone is listening. This helps us to prevent creating different flows that consumes the same data.
Hey Polo, I have a question.
Okay.
Okay, yeah, flow seems good, but it seems a bit more complicated to set up and use than the LiveData that we've been using. Does it have any significant advantages of flow over LiveData in, let's say, in an Android application?
LiveData only helps us to. LiveData is not a reactive. It's not built to be reactive that can give us data as they come. Although, for example, let's take a case. Hello.
Yeah, I can hear you.
So Flow can be able to generate data and send them to our user, and send them to our user as they come. And one drawback that I found in LiveData is that let's say we are doing a mapping operations, like converting our data from one type to the other. LiveData does that on a main thread. So it will continue. It will converting the data in a main thread.
And also maybe just to highlight on some of the advantages is that we have maybe flows being multi-platform, which LiveData doesn't maybe support currently.